Ladies and gentlemen, welcome back to another live stream. So this is a new series of creating a Rust multi-window wgpu and winit engine using the latest versions of wgpu and winit as of recording this video. And we're going to be assisting with AI for the boilerplate code and like exploring new features that I've never implemented before. This is why it's a chill dev stream. I'm not going to be explaining much, but you know, I'm going to have some commentary, that's for sure. Anyways, let's copy the URL here. And so this dev stream is basically just focused on getting things done as fast as possible and as robustly as possible, I guess. But yeah, anyway, so it's less of a tutorial essentially. That's what I'm trying to say here, and infiltrated. Anyways, let me you can join the Discord down in the description below. So live. All right, and let's share them in the rest streams too if I can. Apparently I can't hear for whichever reason, huh? Okay, fine, let's share it here. And let's go. Okay, so let's just pop out the chat here. And let's go. Okay, so we're gonna be actually making like a library which people could use to automate the boilerplate code. Right, because right now everybody is using a different version of wgpu, like winit and stuff, and a separate like math library and so on. I want to basically abstract that boilerplate code, like the glue between wgpu and winit, first of all, and second of all, I want to have people like, you know, share the same dependencies because they're going to share the same crate, which is our boilerplate library kind of. Now obviously it's not just going to be boilerplate, we're going to like build more higher level stuff over it, that's for sure, but we kind of like going to have, you know, multiple crates essentially. So like one core which only depends on wgpu and winit, and maybe what is it called, algebra, wait, yeah, there was like a crate in Rust called algebra, but we'll see about that. And yeah, that's great. And obviously it's going to also handle multi-window, so that's nice. And hello Enze, welcome to the live stream. All right, so let's get started. All right, so let's create a new project, and it's going to be a library. And location. So what we're going to call this, I think let's just call it wgpu so it's searchable. So wgpu code otaku, right? So obviously there was a lot of changes in winit, so this stream would also help anyone who's interested in the newer version of winit and wgpu, like on how to use it. But yeah, all right, so let's create a library really quickly here, and let's go. And I'm using Rust Rover IDE, which is great. All right, so let's just put this here, and let's see what we got. Okay, so do I have the settings done? Wait a second, where's the settings? There we go. Okay, so save actions, yeah, format code, optimize imports, rearrange code, run code cleanup. Okay, boom. All right, so let's see what we gotta do now. So we're gonna definitely have like an examples folder, which is gonna have a binary that we're gonna use. So Rust file, and let's call it, I guess, game.rs maybe. Yeah, just game pretty much. And let's add it to GitHub. No main function, sure, add fn main there. And let's see what we got. Okay. So that's sick. Now we're just gonna remove this stuff. And let's go. Now I'd love to actually split this into multiple crates already. Can we do that? Or, you know, never mind. Let's just stay like this for now. Okay. All right, so let's create a... should we start already like modular, or should we start regular then go modular? let's create a directory called, or just a core.rs for now, or yeah, fine, let's just create a directory called core, and we're gonna have like a mod.rs here, and add, and it's gonna contain mod.rs. It's also gonna contain the graphics context, and it's also gonna contain what else? Yeah, the Windows state, right? So like the Windows surface, etc. Windows state. And what else we're gonna need? I think this is it for now. Maybe we'll see about that. We're gonna need some more stuff later on, but for now this should be enough, I think. All right, so what this gonna contain? Graphics, Windows state, and finally core. Actually, can we do that? Like call it core, can we? I think so. So I could basically say mod core here. Okay. All right. So like the mod rs is just basically it kind of like just stitches together all those files. But yeah. Anyways, so what we're gonna do now is we're gonna have a struct called core, which is gonna contain a graphics context. Hello, Theo Paris. All right, admin, welcome to livestream. Welcome back. In fact, let's start with the graphics context. Fine. Let's start with the graphics context. So let's call it, I guess, GFX maybe. I mean, okay, fine. And it's gonna contain the wgpu instance. Oh, I don't have wgpu yet, so let's actually add that, right? So cargo add wgpu. And we're also going to depend on winit, and we're also probably going to use encase for uniforms. And what else? We're going to need polster for blocking on the async function. We're not going to bother with web right now, but later on we could look into it. And I think that's it. We could add a math library already. So I really love this library. It's like top tier, man. It's really the best out there, and it's also have their own like physics engine, which they dog food their own linear algebra library for, and it's very advanced. All right, so like there is Rapier, which we could even like integrate later on. Why not? Rapier Rust, right? So this like in algebra is, you know, made by the same team who made this Rapier physics engine, and they're using an algebra itself. So we kind of like gonna share the same math library with the physics engine we're gonna use and stuff. But yeah. All right. So yeah, I mean we could add that already. Fine. And other than that, yeah, I think we should be good for now. Fine. I'd love to add EGY or even Velo, which is an interesting like 2D render in Rust. Like it's a GPU compute. It's used GPU compute to like draw vectors in the GPU itself, instead of like, you know, rasterizing into triangles first, then uploading to GPU and drawing there. But what I don't like about EGY and Velo right now, at least, is the fact that they depend on older wgpu versions, right? So that's the problems with the depending on stuff that uses wgpu and winit. They usually depend on an older version. But yeah. Anyways, whatever. For now, we're fine. Okay, so what we got here? WGPU instance. Now, another thing that most people using WGPU actually miss is the fact that WGPU have a very good util library that have some interesting stuff. Like you have a staging belt for efficiently performing mini buffer writes by sharing or using temporary buffers. This is like the industry standard for like efficiently uploading data to the GPU VRAM. In fact, when I was doing my Zig SDL3 GPU stream, I was actually, you know, I fed this into the AI and then I tried to like vibe code, like translate it into the Zig and SDL3 GPU API. and it was amazing. But here we're gonna have it like, you know, built in into the module, util module. There's even a download buffer if you want to download data efficiently from the GPU. From the GPU VRAM into your, you know, system memory for the CPU access. But yeah, there's already even like a function here to easily like I guess initialize some buffer with some data and draw indexed. I'm not sure what's that. And there's even a texture blitter. This would basically give you like a pipeline, so you could easily like copy the texture without having to create pipelines and so on. So like this is a very cool utility for just splitting textures essentially. And this is quite useful. I found it useful when I was trying Velo, you know, the renderer that I've shown you earlier, which basically just draws into a texture and like you have to split that texture into the screen. But yeah, other than that, there's also some device ext stuff and texture format ext, which adds just extra conversion functions. There's also align to, which aligns a value to an alignment, and these functions that are cool too. So initialized adapter from env or default, which means that the user who ran your engine could basically change the GPU they're using just through like the wgpu adapter name environment variable. So you don't have to like, you know, implement that logic yourself, make spur v, blah blah blah. Yeah, and device ext, it contains also, this one contains some code to help you with creating a texture with data, because it's much more complicated than it seems, because you gotta handle like the image, what is it called? The image pitch and stuff like that. I mean, you could even look into the source code here and look at this. Okay, so let's see. There you go. So it's handling some alignment stuff, some padding stuff, and all sorts of weird stuff, right? So, and you get this for free, you know, in the util library, as you can see. So yeah. All right, so let's just go back into business. That's just something I'm gonna use this a lot too, but we'll see. Anyways, so instance, and what else? We're gonna need an adapter, right? So wgpu adapter, and we're also gonna need a device, and a queue. Now later on, I'm gonna actually, you know, start vibe coding, like assisting with the AI. But right now we don't have that much code already, and so we're just gonna, you know, write by hand for now. But yeah. And honestly, I think I'm not gonna copy like code from the AI like previous live stream, because I start to get, you know, kind of dizzy, because I'm not exactly sure which line is which, especially, yeah. So I'd like to have full control, so we'll probably just copy by hand any code that we get from the AI, I guess, just to make sure that we know exactly what we're actually doing. But we'll see about that. Anyways, struct gfx. So right now we're gonna import gfx, and we're gonna add in a fn new, and it's probably gonna be async, I would guess, and self. Right, it's gonna return. Oh yeah, also we're gonna need anyhow. Well, actually, since we're making a library, we can't use anyhow here. I mean, we could use it for the example, that's for sure. So we're gonna add that as a dependency for development. Cargo add div. How do you add a div dependency? I forgot. Cargo command to add div dependency. So div dependency is basically a dependency that isn't like export like for the library. It's only available, let's say, for examples or like the build tools and so on. Yeah, exactly. I'm gonna use this error for the library, but anyhow, I'm gonna use that for the example. So like for the executable essentially. But yeah, so yeah, all right. So cargo add dash dev. So you say dash dev, okay. So cargo add anyhow dash dev, and cargo add this error. We could even add like tracing, but for now it's fine. All right, so cargo add this error. All right, or you know what? Yeah, it's fine, whichever. Anyways, so here what we're gonna do is we're gonna have like some sort of, I guess, an error. Where are we gonna put it exactly? Well, actually, we're gonna have it here. Yeah, fine. So I guess struct error, and it's probably gonna derive from this error, right? Let me remember how this error works, because what the heck. All right, so you just use this error, and then you do stuff, right? So I'm gonna call this gfx error, and we should be good to go. Now what? So we kind of like, for example, gonna have like, let's say, an instance error, and for that it's gonna come from well, what is it? wgpu. Wait. What? What's going on here? WGP. Oh yeah, the syntax error. I see. That's why. All right. So how about now? Can we do this? I don't know. Maybe something like this or whatever. So what's the problem? What's going on here? Oh yeah. Instead of structs, we want an enum. That's why. All right. So let's see where this error thing is inside of. No. Okay, let me see what it's using. Hold on. So we're gonna basically use util. So there is an init function. Initialize from env or default, and if it doesn't exist, fall back on a default. Yeah, we're gonna use this one. Okay. So instead of basically writing this whole code ourselves, right? This part right here, and in fact, this one also calls this initialize adapter from env, which is this whole code. We're just going to use this util function. So yeah. All right, so how are we going to do that? Well, let instance is equal to wgpu util create, well, instance, I guess. No, wait, initialize. Yeah, well, this is actually, oh, my bad. Let's create the instance first of all. Okay, so instance new. So we could just say should we pass in the instance descriptor? For now, let's just go with defaults, please. Later on, we could focus on trying to make this more flexible. But for now, let's just go with some default behaviors. Okay, so expected gfx but found. All right, so we're going to say okay self. And obviously, we're going to pass in the instance here. Next up, we're going to grab an adapter, and we're going to use that wgpu util function. And here, initialize adapter from env or default. But actually, before that, we're going to need a compatible surface. So that's one thing. So let's pass in the instance, and here we're going to need some sort of some compatible surface, right? Yes, some compatible surface. Or should we just pass in like... I mean, we could just pass in like an option here, actually. Yeah, we could pass in the option directly. So we're just gonna like copy this part and paste it here. Compatible surface. Right. Option and wgpu surface. And we're gonna pass in the compatible surface here. And let me just remove this for now. And this would give us an async function. So this gotta be an async function. So pubfn async. Pub async fnu, right? Okay. And here the await. And this gives us a result, so we're gonna do... Oh wait, actually instance doesn't have an error. That's interesting. It doesn't error, but this one does error. So we're gonna go with the request adapter error. And we're gonna say from wgpu request adapter error. And there we go. Cannot find attribute. Really? Let's go back to here. How does that? Oh yeah, we gotta derive error. Gotta derive error in debug. Now what? How about now? And we also gotta do this error thing. Okay. So let's just say error, I guess. Couldn't request adapter, right? Or isn't it? And we just, I guess, say this, possibly. So what's up? Oh, let's actually import this error here. And we should be good to go now, as you can see. So couldn't request error, adapter, and expected found known. Yeah, and here we're basically just going to be like printing whatever stuff this error gives us, essentially. And that's how you do it. Now I could just say this, I think, right? Well, let's actually say now result. So type result t is equal to, let's see, gfx error. No, result. And here we're going to say some t and gfx error, essentially. There you go. And wrong number expected 1, found 2. What? I guess I should probably say maybe a CD result or something like core. No? Where the default result is inside of? Don't remember. Result. Yeah, it seems like it's inside of core result. Or you know what? Let's not overcomplicate things. Let's just say that this is result self, comma gfx error. Too simply. And there you go. Now the adapter, we stored that, and then the device. So for the device, we're gonna say adapter.request device, and here we're just gonna give it a device descriptor, right? Well, wgpu device descriptor default. In fact, you know what I'm gonna do actually? I'm gonna create like a struct gfx info. And by the way, these gotta be public, obviously. So let's make sure to add those. Public, and public here. And what we're gonna do now? Yeah, so we're gonna grab in the instance descriptor, I think, maybe. I mean, I guess fine, we'll see. Nah, wgpu instance descriptor, but this probably gonna need, no? I guess we'll see. And the compatible surface here. So let's grab that too. Actually, let's just put it here. And what's up? What's going on here? Why it's, oh, I see. Can we say the await, and then we got a request device error, and this actually gives us device and the queue. So I guess I could say this. Right. So request device. So what's the error? Request device error. Okay. So we're just gonna like copy this part, paste it again, and here couldn't request device, and then say here request device error. Now, one assumption that we're gonna make just to keep things simple is that you're gonna have like one device, one GPU that you're gonna be using like all the time, because if we allow multiple GPUs, this is not gonna be simplified anymore, you know. We're just gonna be doing the extra work for no reason, I guess. So yeah, so like for an abstraction to be usable, you kind of just have to make some assumptions. Otherwise, you just like recreate the same thing. That yeah. Anyways, cannot find value compatible surface in this scope. Compatible surface, yeah. So here we're gonna grab in some info and gfx info, and let's go. and we should probably get a reference here, and we could say info.compatible surface, and here instead of default we could say new, and here instance descriptor. So like info.instance descriptor. Let's go. And obviously there's going to be like a default value for this gfx info. We'll see about that. And here what? Compatible. So we're going to bother with the lifetimes. So let's just introduce that, I guess. And for now, let's just do this. We'll see. But for the surface, we're just going to say probably static. Yeah, and that's good. Now what? The anonymous lifetime there. And okay, so we got the device, we got the queue. Now what's up? And here this should be called request device error. Is there anything else? I don't think for now, I guess. Another thing that I'd love to add into the GFX is a staging belt, right? So, and one thing I want to ask the AI really quickly here is, let's go to our init. Well, hold on a second. Where is that? Like the util. Okay, let's go to the staging belt. Where's that? The source code. Where's the source code? Because like all projects need to upload, you know, data to the GPU. So okay, let's just copy this. And let's just say I'm making a boilerplate, a library to abstract over the boilerplate glue of wgpu and winit. And I found this abstraction in wgpu util. And when would we need multiple of these instead of having just one shared in context along with device and queue, etc. I'm just wonder when it would be needed, it would be necessary. This turns your parallel command recording into serial process, creating massive bottleneck. Or maybe we could look into this later on, honestly. Could go look into this later. By the way, does these like implement... So I think they're arcs. So they're probably very easily clonable, I would guess. Yeah, I think that's probably the case. Yeah, that's what I remember. But like, I can't find... Where's the implementation here? Wait, no, not here. Is wgpu instance an arc? Effectively. So, I mean, if they're arcs, then we could basically just say, if we keep it like just the wgpu objects, we could easily just say like derive clone instead of making this an arc, in fact. Yeah, I think so. Instead of using an arc. Okay, that's lovely. That's lovely. So if we add staging belt later on, we gotta wrap it in arc and RW log. Arc mutex. So almost every useful interact with the belt requires mutable reference. Okay, that makes sense. That makes sense. I mean, fine. I guess let's make it. Why not? So the belt is wgpu staging belt, right? Well, util staging belt, and obviously right now we're gonna wrap this in an arc and mutex. And yeah. And then we're just gonna create like a staging belt here. Is equal to wgpu util staging belt new, and it takes in device and you just clone that, and then the chunk size buffer address. Okay, so the chunk size, we're gonna get it from the info. So that's gonna be staging chunk size. And this is gonna be like a buffer size, right, or what? Yeah. Now, what's up now? Buffer size, buffer add. Oh, it's actually buffer address. Okay. Well, wgpu buffer address. My bad. And yeah. Now that seems good to go. Now we're just gonna make sure to wrap this into an arc and in a mutex. We could have used also RC, but to keep this, you know, multi-threading friendly, we're gonna have an arc anyways. And let's call this staging belt actually. And we're good, I think. Yeah. Now one other thing is this device descriptor. Now the problem with this device descriptor is that you may want to have access to the adapter, you know, to maybe like yeah, hold on a second, hold on. For device descriptor, I'm thinking of adding a callback that have access to adapter and instance, etc. This is a very solid. If correctly identified that well, our pre-arc the using the callback is a pro move for a library. It allows your user to inspect the adapter features and limits. So this is what I'm talking about here. Or consider it before committing to a device. Yeah, there you go. So callback to customize device features based on the adapter found. Now here we could actually allow the user of the library to like you know, set the lifetime of this, but to be honest with you, I would just assume that the user have like an arc window, you know, so it would always be static. So we remove all that, you know, that weirdness, but yeah. Alright, so device descriptor, they called it factory. That's weird, but okay. wgpu device descriptor static. Now let's just actually copy this line. And it's just a box din fn once, because we're going to be calling it once, and you're going to get access to the adapter, so you could, you know, query the limits, the features, etc. to determine what device stuff you want here. And yeah, I think that's basically it. Now here, what we're gonna say is address of and hello comported box, welcome back, info dot device descriptor factory. And what's going on here? Why can't we just call this now? Wait, how do you call this? Oh yeah, I see. So you gotta basically do this. Yeah, W language, W string. Back to Rust. Yeah, we're back. Device descriptor factory. You know, let me grab this, bro, because this is getting insane. Hold on a second. Let me grab this. And let's just call this descriptor factory, bro. Or just this device descriptor, actually. Wait. Device descriptor. So we're finally solving that problem of everybody rolling their own wgpu, like, you know, boilerplate code. So device descriptor factory. Whoops, remove this. And now I guess we could just pass in the adapter, right? Or no? Or in fact, do we really need to? I mean, yeah, it's fine. So you see descriptor, and you just pass that in, and we're good. Cannot move out, which is behind a shared reference. Hold on. I mean, I think we gotta maybe make this into an option and then like take it out so we could move it, but I wonder if there's like a easier way. Come on. The compiler is complaining because fn once consumes itself when called. It's a one-shot deal. Since you're passing info by reference, Rust won't let you steal and destroy a piece of that reference. Change the method signature. Oh, I see. Alright, I gotcha. So let's just grab the info itself. Fine, I see. And yeah, there you go. Okay, so I think we're done here, right? Yeah, I think we're pretty much done here. Now, what we're gonna do right now is just to give a default implementation for GFX info, I think. Yeah, exactly. So let's just implement default for GFX info. Now, actually here, if I really want this to... Nah, should we like, you know, expose the info of this thing or just keep it this way? Nah, I feel like let's just keep it this way, I think. Otherwise, we could maybe possibly have some other overload or something. But this is a great default. So I'm just gonna leave it for now. I'm not gonna expose that. And let's just say okay, and here what we're gonna say, default. So we're gonna return in self, and we're gonna need an instance descriptor, which is gonna be like instance descriptor default. There you go. And then a compatible surface. Well, since this is a default, you gotta be none. But you could probably say some, let's see, compatible surface. But you could probably like, you know, use this default and then just like, you know, override compatible surface with your surface. Right, so we're just gonna set it to none for now. And then for the staging chunk size, I guess we could go with the 1 megabyte, which I'm not sure what it is, but you know, let me just make this continue. There you go, 1 megabyte is a good middle ground. So let's just pass in that 1 megabyte here. Next up, we got our device descriptor factory. And we could even have like multiple device descriptor factories, like kind of like presets to some degree. But yeah, experimental features and trace. And we're just gonna set these to the defaults. So all of them are, I guess, defaults. Is there a default here by any chance? Yeah, there is. Well, can't we just say default, in fact? No, let's just go with defaults, bro. And there you go. Since returns an option and expects we need a small bridge. What the heck it's talking about here? I don't think. Okay. Okay, let's actually just copy this part. This helpers. So the device, the queue, the adapter, and here a helper to perform a stage write without the user managing the mutex. So essentially it just logs the staging belt mutex, and then it tries to write the buffer. And I guess it just passes the target, the offset, and the size, which is perfect. Perfect. Next up, is there anything else we can like write buffer? There's even allocate and stuff. But yeah, other than that, there's the lifecycle glue. Yeah, sure. Let's say finalize frame. Let's see. Select belt, lock it, and then finish. You would usually call this after the queue submission. Recall. Are you sure we call recall at the end of the frame instead of the start? Okay. There you go. So yeah, let's do something like this then. Begin frame, end frame. And it's going to take care of the belt recall, which basically frees any memory that is, you know, unused, no more used by the GPU. And then the finish here is just like uploads the buffers to the GPU. So yeah, let's remove this comments, no need I think, and we're good to go. Enable this and we're good. Let's remove this part and we're good. Any other helper functions? What this is doing exactly here, and texture upload helper. Let me see. So finish the belt before submission, so data is in mapped and ready. Okay, and then we submit iter, which is an iterator of command buffers. Ah, I see. And it returns a submission in. Okay, so I think they just added this in wgpu, the submission index. It wasn't here before. Yeah, it wasn't here before. Identifier for a particular curl to qsubmit can be used as part of the argument to device pool to block for a particular submission. Device pool. I don't know. Anyways, whatever. And here we just return that submission. So that's sick. But can't we just like maybe merge the end frame with the submit? There's already a util function for a lineup. Anyways, another thing about this library is that we're not gonna bother like abstracting over winit or wgpu. You know, just gonna, you know, obviously just like you know, like expose them. Yeah, that's the case. So we're just gonna say submit here. And it takes an iterator of command buffers. It finishes the staging belt, then it submit the actual work to the GPU. Yeah. Okay, cool. Next. Oh well, close all active chunks and moves them to the closed chunks. Hello, Mini Moments Hub, welcome to livestream. If they call submit twice, the second call might find the belt empty, requiring a new allocation because the previous chunks were already closed by the first submit. They're likely advanced enough to not need the boilerplate shaving library anyway. One more tip, the auto poll submission. Well, if that's the case, we gotta actually keep them separate then. Or isn't it? Or, you know, if they want to do that, they should just, you know, do queue submit. But it's kind of not clear that they shouldn't be called twice. Yeah, I am. Would you like to see how to implement that reps recommendation? No, I think maybe I'm just gonna keep them separate and call it a day, to be honest, because but it's not clear from the API. Okay, let's call this submit frame. And there we go, begin frame, the encoder wrapper. Oh yeah, this one, yeah. That was the one I used in Zig too. Instead of the user managing a raw, your library can provide frame this ensure. Tip from a Gemini addicts. Hello, Hat. I can't really read that name. Hadas Igneo, I guess. Welcome to the live stream. Instead of your user managing a raw command encoder, your library can provide. Actually, yeah, we should do that too. Yep, you should do that. Guided learn. I never used guided learn. I like, what's the difference? I don't know. So yeah, I think I'm definitely gonna be using this kind of abstraction. Sure. Let's add this, I guess, frame. But wait, why it's passing in JFX here? What the heck? Encoder. Oh, because it needs it. I see. Needs it to end the frame. Yeah, use that frame token. Or in fact, we could put it into its own file, right? You break the info into a little more. Deep search is like a script creator, and Canvas is great to pop an idea out because it don't get you a line of thinking. Yeah, I should try that at some point, definitely. But right now, like, I'm not purely just learning. I'm kind of like just, going back and forth. Anyways, let's go with frame.rs here, Rust file frame. And we're gonna have this GFX frame here. I've been using Gemini to learn Python, just learn the data types. Yeah, that's pretty cool. We store the encoder here so the user doesn't have to create it manually. Yep, that makes total sense. Import. The wait, wouldn't it create like... I'm thinking of putting GFX frame into another file, but would it result in cyclic dependency? Because GFX frame depend on GFX and vice versa. Okay, that's cool. Alright, the submodule, if you find that are so tightly coupled. By the way, the biggest ever tip I can give to you is go to Gemini cogwheel and set instructions to Gemini, reduce response time, optimize its memory. What is it? Cogwheel. Instructions for Gemini. Yeah, I'll definitely use that at some point. But for now, let's just focus on this. Alright, you know what? Let's just try this. Okay. So let's just remove these comments. Say things like, remember, I prefer to use Rust and Python to code. Always well suggested. Yeah. Finish the encoder and submit, and finish the belt. And what's up going on here? Type annotations needed. What? Oh, make it public, please. And actually, no, don't make it public. Hold on, go back. I'll just remove this public part, I think. And we don't have access, I guess, to the staging. You know what? No. Let's not do that. Just refactor this to use frame. We will not use multiple files for now. Yeah, let's just remove that because it's just overcomplicating thing on myself for no reason. Let's just remove it for now. And let's just grab, I guess, this code. Staging build, arcmutex, no adapter found, couldn't request adapter. Wait, couldn't request adapter. Why it removed the request adapter error? That's weird. Yeah, I'm not gonna copy paste from Gemini, to be honest. I'm only gonna copy and paste the changes this time. Yeah. So let's just grab this. Oh, the impl drop. Really? Well, that's interesting. So yeah, let's just grab this. And where are we gonna put it? Maybe down there, I guess. Okay, let's remove this comments. And here with sub cell.encoder. I guess we'll find out about that maybe. Then what else? So we got our new function, cool. We got our begin frame and yeah, begin frame, and it returns a GFX frame. Okay, so begin frame. And you don't really need to submit frame anymore. You just say .submit sick and what's up. Okay, so this actually could fail, huh? Poll status. Poll to far map async callbacks for the build. That's interesting. What poll takes in here? Poll type. So there's poll and wage. I would guess poll. And here we're gonna need which error? The poll error. Okay, so what we're gonna do is result. Is it like the only error that we have here? I mean, I guess. So if it is, we could just do wgpu poll error. And yeah, now GFX frame. And here we're just gonna say okay. Like this. Please don't include comments in code. No, the new API uses poll type. If I correct something, probably know what I'm doing. Other than that, what else? Why you changed my adapter error? And yeah. Inside submit. Okay, that's interesting. Submit. Ah. This is insane, bro. So you see what we have here is that we have implemented this drop, which would always like finish the build. So we always make sure to like free any memory, right? Or like, sorry, upload any things that is needed in this frame. But the problem is, since we implemented this drop and this submit actually consumes the frame, what would happen is that this drop function would be called after the submit is ended, right? Which sucks. So we say std mem forget. So we make sure that the drop doesn't execute. So the drop here would only execute on the error path, which is actually quite interesting. I wouldn't even think of that. Oh boy, love that. Love that. All right, so let's add this std mem forget before the index. So where we have that stuff again, inside of submit. Where's submit? I think it's down there. There you go. So let's do, wait. Why are not passing in the, oh, I see. Okay, so let's just say let index is equal to this. And you're going to say std mem forget self and then pass in the index here. Okay, so what's up here? Value used after being moved. No, it's just kind of like, I have noticed a subtle, kind of like edge case to some degree. So what it did, it basically added this drop. So it makes sure even if we didn't submit this frame because of an error or whatever, it would always, you know, call build.finish on this frame getting dropped, you know. That's the first thing. But after it did this, there was a problem because the submit is actually like consuming the frame, and which that means what's going to happen is that once we're done with the submit function, it would try to call build.finish again, which we already called successfully. So what we do instead, we actually try to like forget this, which means it wouldn't call the drop function after the submit. So yeah, it's very, very interesting. So basically, the overall effect here is that if we actually submit the frame successfully, we're good. We only call build.finish in the submit function. Otherwise, if there was like an error and we just dropped the frame and we didn't submit it, then it would just make sure that the build is finished at least. And yeah. And yeah, it got moved here apparently, which is interesting. Let me give it this error. Let's remove this mod frame from here. And wgpu. So basically causing a redundancy of safeguard, very cool, depends. Yeah. Also, we have this error. Let's go. The error occurs because self.encoder.finish consumes the encoder, moving it, but types with drop can't have their fields moved. Oh yeah, I see. So it basically just makes it into an option and does moves. Okay. So essentially this finish function, it's kind of like this submit. It basically consumes that encoder, and so here we cannot really move it if we consume it. So what we're gonna do is we would have an option encoder, and encoder now, instead of this we could just say as mute and just .inwrap, because we're sure that this would always be on. It's just that this encoder would be used in the submit. Other than that, what else? So here .finish, what are we gonna do? We're gonna say .take, so we're gonna take it off. Cashiers, I see, man of culture. Yeah, cashiers is amazing. Cannot borrow make self mutable. Sure, let's make it mutable. And let's go. This is perfect, bro. Expected option, sure. Can we just say sum? And what do you mean finish is not there? What the heck? Oh, let's unwrap this. And we just got like some sort of apparently some stuff here. Let's just use this. Wait, mod core. This should be public, bro. And let's go. Would that fix that issue? No. Yeah, it's just because it's not probably public yet. That's why it's. Okay, cool. So right now I removed that. And field instance is never read. Well, for now. Okay, cool. Alright, so that's perfect. So this works. Cool. So this is what we got. Okay, one-time logic, and you should check if encoder is sum before calling bell.finish, even though finish is mostly harmless if called twice. What? What do you mean, bro? I guess this have nothing to do with the command encoder, no? No. What the heck? The current GFX is headless, it doesn't have a window. Since you go to abstracts over winit, the next is a surface wrapper. Okay, well, I see. Let's just focus on GFX itself for now. Any other helpers? Why the heck you would want to create an empty buffer? What? Bro. What does that even do? Kinda confused here. Oh, empty. So this one actually uses init. But no, I think init sucks. No, I'm not gonna give this, cause I mean it could still be useful, but yeah. Anyways, let's just create this. Fine. Let's add this, and we're just gonna call it create buffer. And here's self.device. No field device in GFX. Oh, my bad. Let's grab this from here. And let's come to, I guess, here. And that's good. So use think mode if available to try and make it give a better answer very necessary. Use too much text, click on fast. Think mode, I've never found it better, to be honest with you. It just like overthinks and it's too slow. So that was my experience. So yeah. So that's create buffer. Next step, shader module, sure. Let's also add that. So it just assumes that the user uses WGSL, which is great. And immediate texture upload. And honestly, let's just add this too, why not? Just in case we ever need it, I'm gonna say init buffer. Though to be honest with you, I think instead of using this, we may just use the staging. Wait a second, instead of create buffer init, shouldn't we just always use staging belt? Or is there still a use case for it? Shader module shortcut. Oh, are you sure create buffer init does do that? Because I think what create buffer init, it just makes the buffer CPU like accessible, and it just, you know, writes the data into there instead of VRAM. So maybe I'm wrong. So what we're gonna do is check out this create buffer init. Let's see. Yeah, I don't think it uploads. The belt uses stage in memory. The other thing that I also want to let it know that Gemini basically has amnesia. I mean, that's all the models pretty much. So yeah, alright, so what I'm gonna do, one tips that I have for that is to always make sure you kind of like, for example, let's say you want to refactor, let's say graphics.rs file, then always go ahead and like refresh its memory by just copying the file into its context immediately, instead of depending on what, like the fact that you have already told it the file. So you just kind of like refresh its memory. But anyways, what I wanted to do, yeah, so create buffer init, and there's even create texture with data. But you know what, let's just see about this first. Let's handle this stuff first. Alright, wait a second, let me open up that window, because oh my god. Let's see. I don't think that's the case, but you know, oh no, wait. It's taking descriptor.usage. What? Yeah. But it still handles some alignment stuff, apparently. Okay. Bro, what? My point is that we want to only provide the GFX frame data helper. Deployed the buffer. Alright, yeah, fine. Let's just grab this function here. So I think for now, I'm just gonna remove that buffer init, I believe. Or, you know, we could just keep it in case ever someone needs that, I guess. So fine, whichever. Init buffer. And this one is create buffer and then finally upload buffer. Okay, upload buffer. What? Whoops, what? Is this inside of... Yeah, I think this is supposed to be inside of frame maybe? But no, that shouldn't be the case. What the heck? Is it using the staging belt here? Where's the staging belt? Nah, what the... This is weird. Does the staging belt really require an active commanding? I don't think. What the heck? Oh, the other nice thing about this kind of GFX helper, instead of like having it tied to the surface, we could also do something like this without having the window stuff. Well, yeah, the upload, but the allocate, no. Okay. Yeah, I see now. I get it. Fine. Because I was confused at some point there. Now let's go back into business. Where is that? Bro, graphics, right? There you go. And let's see what we got. So, right buffer, right build.right buffer. Okay, in the frame here, we're gonna add this upload thing. So you give it the target, the offset, and the data. And yeah, so this helper hands the encoder, copy buffer, logic internally, write buffer. And there you go, self.encoder. Though in fact, instead of doing this, I believe we already have a GFX write buffer, right? Yeah. So that's sick, but why we need this size? Oh, because we're getting a slice of data. And then here we say view copy from slice. Yep, it makes total sense right now. Love that. Makes total sense. So yeah, all right, so this is great. This is amazing. Love that. We'll just create a frame at the beginning and use it for initial setup, like uploads. So all the uploads would go through staging belt instead of having a separate upload buffer for every data. So yeah. Yeah, I get it. So I got we can add the tiny alignment helper. No, let me show it that the fact that wgpu already have a utility for that. Where's util? Align. Where's align? What the heck? I'm pretty sure it does. Wait. Bro, really? Go back. There you go. Okay, let's see how it's gonna use that part. So it's doing it here. Ah. Would in case have helped here instead? Or is align to the most what is it? Optimal here. Yeah, no. It's a different story. Yeah, I think it's a different story. So in case is more for like uploading structs. In fact, we could add that, yeah. So you give us some buffer and then you give us some data struct. And here just creating, but this is only for uniform buffers. I mean, obviously like structs only works for uniform buffers anyway, so that makes sense. Yeah. Anyways, let's do this. So what kind of code we have here? Hold on. Let me see. Upload buffer, okay. So let's replace this with upload buffer because we need to make sure that the data size, or like the padded size here, or like the size of the buffer essentially, is aligned to wgpu copy buffer alignment, which is like 4 bytes. So for the copy to be successful. So yeah, other than that, we're good there. And here it's actually making sure that we only touch the in padded portion and we copy from slice. Sick. Now let's also add this one, why not? That would be also very useful, like let's say for uniforms, like the camera structure or whatever. And did I already add in case? I think I did, right? Yes, I did. Cool. So we get some in case shader type, and then target wgpu buffer data. Here we create a uniform. I mean, is there anything else? Hold on. What else there is there? Okay, so there's uniform buffer, dynamic storage. Okay, so storage buffers too. And I'm not sure what this matrix stuff is for, and like vector and so on. Yeah, I'm not sure what's that, but yeah. Anyways, so buffer write data. So we gotta add this in case internal write into, I think. And then, so you create a uniform buffer with a vec. Really? Okay. And then you write data into that. And then into inner. Yeah, it gives you back the vec. Gotcha. So you basically like pad the struct data manually into a vector of bytes. And then you go ahead and upload that, right? You still need to align the resulting byte slice to 4 bytes. So basically we need both here. Well, that's interesting. So now let's actually give it that error. Could not find size in wgpu. What? Well, util. I mean, we could just do this, but let's just ask it and see if we're missing something here by any chance, or is it just the fix? But wait, in case internal. The shader size trait, yeah. Wait, what? Are you sure it's supposed to be used by the public API? Because it is internal. It's called every time. If you use this in your main loop, that's a lot of small allocations. Oh yeah, that's actually true. We should actually do that, yeah. It is a massive keep out sign. Hello, overdue RG. Welcome to the live stream. Welcome back. Yeah, there we go. Come on, bro. What the heck? Is there... Wait. Or you know what? Let me check out the documentation because the AI is tripping right here. What the heck? Yeah. Fortunately, it doesn't seem to say which one should we use. Dynamic storage buffer. You know what? I think I'm just gonna use that and call it a day for now until we see something else. Yeah, let's just use that. Fine, who cares? Unless if we could also try maybe whoops, in case like uniform buffer. Nah, never mind. Let's just go with this, bro. Let's just go with this. Fine. All right, so that's it. Anyway, this is what we got so far. That works. Can you add that vec optimization? Also, can we add functions for slices in regular data? Maybe using BiteMuck. Okay. Which model are you using? Gemini, just the free version, the fast one. Okay, so let's add this scratch pad. So there you go, scratch vqh. The weight, does it actually? Yeah, it should. Kind of not really. It's fine. Like I'm not really like generating the whole project. I'm kind of like just going back and forth, just kind of like, you know, handling one small bit of a problem and just seeing what kind of suggestions it's come up with, etc. And also the boilerplate code. So I'm not like, you know, dependent on it like fully, you know. And it's way more than enough for my case. And it's also very fast. So yeah, that's something. So now here in our employed struct, instead of creating a new vec every time, but we could just use the self.scratch pad. And let's go. Consider cloning. Wait, what? Oh, does this consume it or what? I guess. What? Oh, I think we could just say mutable, right? Yeah, perfect. And what we're doing here? How do we do that? Or you know what? Let me just take this. So first of all, we need to actually clear the scratch buffer. Well, I guess we could just do maybe this. Is that the case? Yeah. Well, not really. Wait, what? You know what? Let me just do this. Do this. And just run. Give it the error. Missing scratch. Add it, please. Wait, what? Hold on. Didn't we actually create the scratch Vic already? Apparently, I guess we haven't, so let's just create it. Fine. Let's scratch is equal to Vic. Wait, capacity. And what capacity you use it? There you go, 1024. Okay, sick. And let's add bytemuck for zero copy basic data. So cargo add bytemuck. And there you go. Okay. Now we're gonna upload the slice here. And bytemuck works great for slices, for example. Cannot borrow, self is mutable. Really? Perform upload target. Well, that sucks. That sucks. Now that's hacky. Is there another way to handle such a case? Maybe some pattern or crate? Yeah, so like this kind of caching things always gets in trouble. I just want to have the API. Hello, Even. Welcome to the live stream. I just want to have the API not being affected by having a cached field. Not really vibe coding, more of assisting with AI mostly. Vibe check coder maybe. Yeah, that's a better way to put it. I hear you. If you want a transparent cache that doesn't affect your API with borrow checker issues, looking for interior immutability. Yeah, caching really sucks in Rust. The standard way to handle this in Rust. Or is it not worth it? By using refcell, upload struct in case can take self without locking the entire struct from being used as source or other parameters. So we borrowed the mutable, scratch clear, uniform buffer, blah blah. Yeah, okay, so I guess let's try that. So we're gonna make the scratch refcell. So basically instead of borrowing at compile time, we're gonna borrow at runtime. So scratch refcell std, or to simply just import it, fine, whichever. And then what we're gonna do now is, first of all, we're creating the scratch. There you go. So we're gonna make sure that we have a refcell here. Whoops. And we're good. Other than that, what else? Yeah, let's go right now back to this upload struct in case, and let's just copy this function. Upload struct in case. No need to call it in case, but yeah, no need, I think. Just upload struct. And it's still having that problem. Oh my god. Which is more for rec refcell is the standard tool. Ah, yes, that's way better actually. That's way better. So I think if I understand well, we're gonna make this, instead of a ref cell, we're gonna make it an option. And what's this called? What's this pattern called? Atomic move, I guess. To temporarily steal, yeah. Yep, that would work. That would definitely work. You know how much times this option kind of take pattern helped me in Rust? Oh my god. So what we're gonna do is, where is the upload struct here? So instead of this business, well, honestly, I'll just copy this, fine. And so we're basically just gonna move that scratch buffer out of there and do whatever job it wants to do with it, then put it back into the struct when it's done. And there you go, so that works. That fixes the borrow checker issue. Now we temporarily take the scratch buffer out of that struct, stdmem.take. Can't we just say dot take though? I think we could probably just say take like this. And dot inwrap. But why stdmem take doesn't give back like huh. Wait. Huh? Oh, it replaces it with the default value. But wait, isn't that the same thing here? I'm confused. Why? Hold on. Why stdmem take gives t, but option take gives option t? Okay, fine. Keep it with stdmem take. That's interesting. Okay, let's keep it that way. So let's just remove the comments for now. And the scratch, let's make... Actually, no. My bad. stdmem take itself also returns an option. I'm not sure why I didn't, like... notice that. Like, bruh. So fine. Let's just say dot take. Never mind. And let's just say enwrap here, and we're good. So scratch dot clear, and then we use it for this. Now is empty, so there is no conflict. Cool. And put it back for the next call. Don't tell me something is weird going on here again. Oh yeah, some. And we're good. Alright, so oh. Let's just say some here. Okay, cool. Alright, finally. Oh, no way, bro. No way. I think I'm just gonna remove that drop logic, cause what the heck. Yeah, nah. Yeah, mem forget sucks. I don't care, you know, if the function fails, we're already in trouble. So who cares? You know, I'm just gonna remove that part. Yeah, let's just go with this. And let's remove that stdmem forget, because it's such a big problem. And let's just return the index directly. I mean, yeah, it's kind of clever, but nah. Such a... because I didn't even think about that, because I forgot, like... Anyways, we're good now. Other than that, next step texture help, sure. I think we may just hard code image, but not really here. Maybe let's keep this wgpu only. Yeah, so far we only have this as wgpu stuff. Okay. So let me give it that utility function that we found, I think. first so it doesn't reinvent the wheel for no reason. Where's wgpu util? Alright, so where's that texture stuff? Where's that texture? I think it's probably in the init. No? No. Device probably, yeah. There we go. Ah, yeah. But at least you would kind of like inspire from the logic that is here to use the staging belt. As you can see, it would basically copy that logic that we have in that function and use it with the staging buffer instead, right? It's using, yeah. Well, wait, where's the staging belt, bruh? I'm confused, wait. I mean, let me just copy this first. And this goes into the GFX frame. Alrighty, love this. Let's go to GFX frame. So as you can see right now, we got helpers for uploading textures efficiently, uploading slices using bytemuck with 0 copy, and uploading structs with no alignment issues. So that's perfect. And let's actually remove this part. I don't know why I included it. And let's go. Yeah. So is it using the staging belt? Yeah, it's using right buffer, which uses the staging belt, right? Yeah. So that's cool. That's lovely. But wait, you need access to the belt's internal buffer, huh? Wait, where? Okay, let's give it the staging belt again. Interestingly, you couldn't choose, I guess, maybe the upload buffer thing that we have, but we'll see about that. Okay. So you can't reuse upload. Oh. But wait, doesn't the staging belt itself have like a texture function thing? No? Wait. Am I tripping? No, it doesn't. Okay. Cool. Usually just need 4-byte alignment for buffers, but textures copying row by row, okay, and leaving gaps, padding. Gotcha. How long are you gonna stream today? I'm not sure. I mean, usually I stream like for around 4 to 5 hours. But yeah. Sure. So unreadable. Ooh, look at that. Okay. Let's go to GFX. Where's GFX? Oh, this is getting huge, bro. We should probably move GFX frame into a separate file. But yeah. And what the heck is going on, bro? Oh. Wait, the staging belt. Here we lock it and we just throw away the lock. So no. The cleaned upload texture. And copy swizzled, huh? I don't know what's that magic, but we'll see. Upload texture. Yeah, alignment was always the bane of my existence. I mean, I kind of understand them, but at the same time, I don't. But yeah. Upload texture. They're always so finicky, you know. There's just a lot going on. Other than that, let's just do this and in fact, let's just give it the error, yeah. Can reuse it if you ever need to pre-allocate buffers. Keep the borrow checker without needing take. Okay. Now, if we weren't using Rust, this would just like crash and you have to figure out what the heck have crashed there, what happened. But here, since we're using Rust, these issues never happen. Encapsulated locking will change the helper to take immutable reference instead of hiding a lock inside it. Okay. Uh, okay, whichever. Let's just copy this. So I think maybe just remove that lock function, maybe. Let's go to here, upload texture. And we're good. And I guess maybe we're not using .allocate, right? Yeah, we're just using the belt directly, I guess. I think, yep, perfect, lovely. Now let's just make sure that this is at least is being built. And yeah, I think we're probably good for now. Sick. The easy path optimization. Yeah, where's that? Oh yeah, so if it's already aligned well, then we just, you know, do one copy. But if it's not, then we're just gonna like copy one row after the other, which is a bit slower, but well, it's required. All right, so that's great. That's amazing. Yeah, great. So I guess we're done here. Well, I'm gonna need 3D textures later on for Skybox, I guess. Is there some problem with my current code? So I guess no changes required anyways. Okay, now can you just add some helpers for starting a render pass, etc. So we could move to the next thing, which is like the surface handling, which also suck. I mean, I was thinking to just put it in the frame directly. Well, actually, no, maybe not here, because here we don't have the, yeah. But I mean, we could still possibly use it. I don't know. No. You know what? Let's just skip this for now. Yeah, I think let's just skip this for now. Now we gotta move to Windows state, which would contain arc winit window, and wgpu surface. wgpu surface that needs to be recreated on resume and destroyed on, what is it called? On suspend, yeah. And what else do we need? Static. And obviously handles the reconfiguration of the surface. Okay, let's go. Okay, so we got the surface and the config here. So this is like the volatile part, which is going to be basically recreated every time and so on. So the Windows State Manager, likely store in your winit GFX surface. Yeah, perfection. Okay. Should those be in the same file? Okay. All right, and okay, implement window.rs, fine. Actually, before that, let me give it one thing really quickly, which is the wgpu example. So it handles, because like the surface configuration is very finicky. So yeah, let's go to wgpu GitHub really quickly here. In fact, I should have done this earlier, in fact, but it's fine. Let's go to examples, right? Where's example? There you go. Standalone, hello window, src, main.rs, and let's just tell it that. By the way, here's the official wgpu example. And in fact, wait. Well, let's make sure that this is the right version. Which version we're using again? wgp20h, v20h. And let's copy this. And let's go back to Gemini. There you go. So as you can see, it picked up on some tricks maybe there. Yeah, I picked up some trick. Love that. Okay, so let's go ahead and create a window.rs. Is King Bob, welcome to Livestream. Is developing without AI just not a thing anymore? Obviously, this is more efficient, not having to do everything manually. Not hating, by the way, just genuinely curious. So right here, so there's two kinds of, AI development, like vibe coding, as they say. There's the kind where you just like, fire up a agent, an AI agent, and it just goes ahead and it does that things for you, and you have no clue what the heck is happening, and you have never wrote the code before manually. That's the kind of bad type where it leads to slop, where you have everything so, all over the place and bad architecture and stuff. Now, since I have a clue what the heck I'm doing, I'm very familiar with the Rust ecosystem. I'm very familiar with crates, so I don't have to reinvent the wheel. I have used several APIs before, like wgpu, Vulkan, SDL3 GPU, you name it. So I have a lot of experience on this. So here I'm not using AI to just create the whole thing, just go ahead and do this. Now I'm giving it exactly what I want, so I just don't have to rewrite the syntax myself. So it's kind of like just the syntax part, first of all. And the second thing is that I'm using the AI to suggest me an initial kind of like prototype to some degree, right? Some initial code where I can go from. And then later on I could tell the AI this is not how I want it, etc., etc. And I could nudge it into the right direction. So yeah. And especially at the start where you're just starting out, you probably want to write the code yourself. And then later on, once the AI has some context from your existing code of your style and what you're going for, then you could use the AI to even generate whole files, as you can see here. But yeah. So that's my own opinion. So you basically give it your own built-in blocks and rearrange it accordingly. Honestly, yeah, exactly. That's how I'm using it. So you could watch this whole stream and you figure out exactly what's going on there. You'll see exactly how I'm using it. So yeah, anyways, let's go to the next step. Although some things are still kind of vibe coded, like for example, I'm not very experienced with alignment issues and padding and stuff, so some parts are indeed just vibe coded, so I'm not even sure if they're working yet, but we'll test them later. But for example, this texture layout, but for those, even then, I actually did give the AI some reference code, right? I gave it first of all the utility function, already an implementation to our wgpu. I give it that to get inspiration from, so it uses my own staging belt, because the official wgpu function in the util library, it doesn't use a staging belt. It just creates a whole buffer only for that particular texture. So it kind of doesn't upload it doesn't optimize the uploads for you. It's kind of just upload one texture at a time to some degree, right? But using our staging belt, it's very efficient. So yeah, that's basically the case here. All right, and obviously I'm still working on this. So every time I find some more techniques for kind of I iterate even through my way of dealing with the AI, but yeah, with time and experience. Other than that, we're good. So what we wanted, we wanted this window.rs. So we already have Windows state here, but fine, let's just call it window. Rust Rover also helps a lot with the refactoring. As you can see right here, for example, I refactored this and it just renamed it, but yeah. And Rust overall itself helps me also with problems that the AI misses, like the thread safety problems, the borrowing problems, yeah, all sorts of things, because like those are compile errors. And again, another thing that I really love about, you know, matching vibe coding like with AI and Rust is the fact that Rust ecosystem is huge. So in my, let's say, Zig streams, I had a lot of trouble because I had to, like, you know, mostly redo everything myself. But in Rust, there is like in case for alignment stuff, for uniforms. There is wgpu for you know, GPU stuff. There is winit. There is this error. So like the ecosystem is very, very rich. So yeah, that's basically kind of the case here. And in fact, here we're not even like making an engine necessarily. So this whole graphics.rs right now, we're not really rendering anything yet. Right now, we're just like getting the boilerplate out of our face, right? And in fact, this is a library that is meant to be used by other people. Another thing about this, other than the boilerplate, is that if people use my library, they can all agree on the same, you know, crates, like in algebra for math, let's say, and also the same versions. So we don't have to deal with like these issues with, you know, version mismatches every single time. So yeah, this is kind of my vision right now, and I'm just doing this live pretty much. So yeah. All right, so let's go to window RS. Hopefully that gives you like a view, like a glimpse over what I'm going for here. So yeah. All right, so what's going on here? Let's see what's going on. Okay, so what's the errors? Is it like, so here we're getting GFX. Oh yeah, pubfn instance self wgpu instance and self.instance. Does it work now? Yes, perfect. In wgpu, blah blah blah. Okay, so let's verify if this code is correct or no. So we got the GFX surface, we got WGPU surface, and it is actually static because we're using an arc. And here the config, surface configuration, and we store the format with the sRGB to use when creating views. Okay. Next, so implement GFX surface. You get a new GFX window, arc window, winit. Window inner size surface. Get capabilities. As of, we actually need to, how about the errors? Yeah, right now it's just like handling the errors like just like that, you know. No, we don't want that. Since this is a library, we need to handle errors more gracefully. And so what we're gonna do, no, can you implement errors using this error like we done with GFX? Also pass in any descriptor structs from the user like we done with GFX, but provide a default implementation. And what else? If anything you think depends on a previous object that isn't visible to the user, then make it a callback. like the, what is it called? Like the descriptor, the device descriptor callback. And we're going to give it the previous code to refresh its memory. And there you go. Create service error and service error. And here a callback for config factory. It gives you the service capabilities, and then the user could exactly like configure their own service configuration. And here even we got desired maximum frame latency, present mode, usage, blah blah blah. So that's sick. And obviously it also gives you a default implementation, so if you don't care. And the default implementation apparently uses vsync, 2 frames of latency, and render attachments, blah blah. You got the point. So yeah, pretty much. Yeah, I think that's perfect. So just copy this and let's go here. And let's paste. And we're good to go. So there you go. There you go. Absolutely love this. So now what we gonna do? So the window service, I think we should just like straight up just use it right now. Yeah, I think we just should use it already. I mean, or no. Let's have, yeah. Now, can you create another file that holds a hash map of Windows states, right? Is it called a Windows state or GFX services? Should we bake in the, yeah, we should bake in the graphics. In a similar style. Alrighty, look at that. So right now it's picking up on my style. So it's using this error for errors. Perfect. It's like, yeah, that's lovely. Oh my god, I love this. Yeah, exactly. Exactly. So let's just take this and put it in manager. Add. Do we have any errors? Nope. Lovely. And enum. Yeah, so as you can see, it just creates a GFX. It takes the GFX info from the user. Though maybe it should just like give it also a default implementation. No? Why this works well. Single GPU, many views. You only want one GFX, one device, one queue, because cross-device communication is expensive and usually unnecessary. All Windows share. Now, obviously, as I said, we're just making the assumption that you're only going to need one device, because, you know, like if we try to handle multiple devices, this would probably suck so badly. I mean, we could maybe take a stab at it at some point to maybe support it, possibly, but for now we're fine, please. Using window ID make it trivial to integrate with winit's application handler. Because if you go that route, it becomes too flexible that we're just gonna drown in decisions like should the GPU, like should the Windows share one GPU or should each group of Windows handle one? Yeah, it just becomes a freaking mess. So for now, let's not go there. But yeah. Okay, event loop create window. Though honestly, instead of just grabbing a window, Can you just not like create it? No, it would need like access to the event loop, which is not, I guess, the best. So yeah, it's better to just keep this as a manager, so it doesn't know how you create a window. It doesn't give a crap about that, so you just get a window and it, you know, register it into the manager. Yeah, fine, whichever. Although it could have been very convenient to like just grab the event loop here and the window attribute. Honestly, let's ask the AI and see what it think about that decision. What do you think about the window manager taking a window attributes and active event loop and create the window itself to make it more convenient? Or is it bad design? Yeah, this is what I mean. So should we just go for it? Yeah, great. So right now, instead of having to like create the window and then pass it to this GFX manager, no. You're just passing the window attributes and the event loop to the GFX manager and it creates the window for you. There you go. Yep, that's lovely. That's amazing. Add helpers for... Or no, we don't have a renderer yet, I think. No? Wait. Actually, add a helper for requesting redraw for all windows, because we'll need that in about to wait. Why this is a production grade setup. Add any other helpers that would be useful. And regen whole. Yeah, like getting the format. Like getting the format. Or should we? Yeah, wait. Should we really do that? No. Let's not think about that for now. I guess fine. Whole file. Yeah, another assumption as well that we're doing is the fact that, well, we're using winit, so we don't have to bother splitting the wgpu and winit logic, because, you know, at that point you're just like, you're just like not doing anything. So you're just gonna be wrapping for no reason. And this git render tools, I'm not sure about that part. But for now, let's just grab this and let's put it here. And let's go. Turn the window count, get the window, remove the window, handles resizing, suspend the window. As for suspend, I mean suspend like happens for all windows. And I think the same for resuming. Yeah. You know what? Add a helper for suspend all. Because we'll be suspending all windows. Also, don't include any comments. Region whole file. Is that getting the window attributes? Yes, it does. Cool. And where's the suspend all? There you go. Cool. Okay. Or yeah, that's good. So the manager, we pretty much just like, you know, vibe coded it, because like the AI already have context of how like our code style in graphics and so on, like using this error and so on. So yeah, that's pretty cool. Is there any? No, that's fine. All right, so now, right now we're not gonna have any code. Let's just remove this. So pubmod graphics and pubmod manager and pubmod window. Okay, lovely, lovely, lovely. Now use the abstractions we made in game.rs example to clear the screen with a color. But wait, before I do that actually, let me give it the winit example. Winit GitHub. Which winit version I'm using? 0.30. Okay, let's see, 0.30 tags. Which version exactly? 13. There you go. So 3 days ago. Examples, window.rs. Okay, and let's go to here. Though maybe it's too huge for this. Cause yeah, it's kind of is. Wait. Well, that sucks. So let's just search for this part. It got like cut off. And what part we need? Here. It's a huge file. Or is that really necessary though? The remaining code isn't that big of a deal, I think. Yeah. Yep. Okay, so fine, it's fine. Alright, let's see. So would this work or not? Okay, we have some errors. So first of all, apply order, the right order, and what else? Import the GFX manager. Anything else? GFX surface info, import it please. Add some missing fields. Honestly, I should give it like the wgpu example again. Fine, let's do that. Here's the official example of my wgpu version. And let's see if it's gonna get it. Should we use nvlogger? I mean, fine, whichever. Add it. And now what? Let's see. Did it at least fix that part? No, it didn't, for whichever reason. I'm not sure why. Yeah, it missed that, but fine. Let's just fix them ourselves at this point. Fix the order. Let's import GFX info, GFX manager, and we're good. Okay, what else? Instead of my crate name, I'm gonna say, I guess, wgpu code.taco, right? Well, what? No, just remove this part, because we already have imported that stuff ourselves. And what's next? GFX surface info, import that too, and let's go. It seems like there's no errors anymore. So let's try run this and see if it works. Well, let's switch to let's add a new configuration, cargo, and this is basically example, like game, and run -- example game. What? Invalid working direction. Oh yeah. Well, for that, we're just gonna go, I guess, with rest rover projects, go to Chaku, wgp code.taco. I mean, for now, we could just set it to that, I think. So run, and let's go. And boom. We got our window. You missed a few things. So here's the fixed working code. Can you please use anyhow? Yeah, congrats on window. In fact, we don't have just a window now. We can use multiple windows now. Just hold on a second. Nice catch on the multi-view mask. So like we've done all that hard work at the start, so this part would be a little bit easier and organized. But yeah. In fact, we can like, there's also this winit boilerplate code of, you know, doing all this crazy stuff. We're gonna handle that too with a separate abstraction. Nice catch. In fact, we are gonna even add like a input module, which allows you to kind of like fetch the input as state instead of like events. And the same thing with time. We're gonna have like a time module, which would easily give you the delta time and so on. But we'll see. So for those, we'll just like add them over our existing abstractions. So the users of our library, which is first of all ourselves, they wouldn't have to like, they would just use whatever abstraction fits their level, you know, the things that they want, and just ignore the rest, kind of. So this is the problem that I find with engines. Like, it's either low level, too low level, or high level, too high level. So yeah, too low level, you have to worry about, you know, wgpu surfaces, shaders, pipelines, and all sorts of craziness. And too high level, you have no control. But yeah. Okay. And that works perfect. So it's using anyhow for our executable. That's lovely. Great. So let's see what it's doing actually here. So we have an application, and it only have one field, the manager, GFX manager, right? And Albert Insurer, what? Insurer manager. It's using Polster to block on that async function. Sick. We gotta handle the web stuff later on when it comes to the async crap, but for now we're fine. Next up here in the resumed function, we ensure that there is a manager, and we create a window attributes with this title, and then we use the manager to create a window. Wait a second. Okay. Wait a second, wait. It's not, I don't think it's filling out the compatible surface just yet. Yeah. Well, I missed that. So how we're gonna deal with that, I think, is that we're probably gonna make GFX lazy. Yeah, we're definitely gonna do that. Okay. We missed something. We gotta make GFX lazy initialized on first window creation as to passing compatible surface. You can still use the default impl to initialize the rest of the fields though. GFX info. So I'm just kind of giving it some pattern to make sure that it uses it. And let's go. Did I give it the code again by any chance? No, I haven't. So let me refresh its memory really quickly. Alright, so right now, as you can see, GFX is an option. And it only gets created once we try to create the first window. Though here, it's actually assuming that we're using Polster. No. Should we let it do that? I wonder. Did it use that pattern that I've told it? There you go. Compatible surface, some surface, and then default. Lovely. But no, here, I mean, it does need to grab the GFX info from the user, the initial one. Instead of doing GFX info, okay, let's just see if this code works really quickly here. No, we got some errors. Make it public, please. In fact, make everything public here. Yeah, I think. Yeah, fine, whichever. And next, what else we got here? No such field. But wait, why do we even care about this? Ah, I see. No, what I really meant here is you would say self.info. Is that the case? Where's the info? Isn't it like storing it? Ah, it's called GFX template. Can we do this? Yeah, there you go. That's what I'm talking about. Expected winit window but found arc. Oh, this guy. Ah, I see. I see. So what should we do here? Should we change that or... Oh wait, we're using window created surface. I guess let's just grab maybe an arc. I mean, yeah, fine for now. Well, we could make it an option though. And then here we could take it, because we're going to be doing the initialization only once, really. And dodge in wrap. Fixed a few issues. I'm not sure what he added, but fine. It seemed like maybe it added default here. Huh. Okay. So let's just give it that. And now we're good. Now we're gonna make it use this. Alrighty. Okay, what we gonna do now? Oh, what? Should update GFX new and likely to accept an existing or have its own. Wait, what? I see what's happening here. So this is causing us a lot of trouble, actually. So there's quite a few options here. I feel like that's too hacky. We should either remove instance from GFX or just create a temporary window at init. Yeah, honestly, creating a temporary window at init would be even nicer, maybe. Temporary hidden. This is kind of like OpenGL context trick, but okay, so instead, I guess, of creating the instance there, we're just gonna get it from outside. Fine, whatever. Okay, so let's go ahead and do this. Let's go to GFX. Where's GFX? Graphics. And let's just, I guess, put it here. So like, basically you would pass in instance to new. But wait, if you do that... Oh boy. You know, should we just try to... So my problem is that the defaults right now wouldn't work anymore. Okay, instance is very cheap and doesn't require a window. Well, let me do this GitHub stuff first. I should have done this actually earlier, but fine. Let's just do init and I guess commit, right? Let's also add these, this, and this, and we should be good to go. So like, yeah. So let's try to add to VCS. Okay, so you know what we're gonna do here is we're gonna come here, though it's kind of huge, so hopefully we wouldn't miss anything. Okay, or you know, we could just fix this ourselves because it's probably not a huge issue really. Yeah, let's just fix it ourselves, fine. Fine. So what we're gonna do is we're gonna take in an instance, and actually we're gonna keep it here, yeah, but now instead of creating the instance and having the instance descriptor inside of our info, what we're gonna do, just gonna remove that, and yeah, that's it. That's it for the graphics. Now we gotta make sure to refactor the manager. Or, I mean, yeah, fine. Okay. Bruh, really? Yeah, let's just say here descriptor, right? Instance descriptor default. And there you go. Just go with default, I think. And let's go. Okay. And boom. Finally, we fixed the issue. Lovely. Okay. I fixed a few things. Now, can you add more windows? Rust Rover versus VS Code. Rust Rover, definitely. It's just much more specialized and have amazing refactor tools. Okay. Now in resumed, we could do this. And boom. So right now we have multiple windows. The one problem I always had with this winit, for whatever reason, this version, for whatever reason, it segfaults when you close all windows. I'm not sure why. But yeah, if anybody knows, please let me know. Could be a bug right currently in winit, but anyways, so as you can see right now, this is the whole library, right? So someone who's using our library only needs to do this stuff. They don't need to handle the surfaces and all that bull crap, right? So you just create a GFX manager. In the resume function, you wait, what? Manager window count. So basically, if we already have some windows on, then we just resume all of them, and then we return. Otherwise, we actually create them. So we just define some titles, then we go loop through all the titles, we make some window attributes. Then we block on create window here. We pass it the event loop in the window attributes. And I mean, honestly, in this case, Polster is only a dev dependency though. Where is Polster? Here we go. Currently, we're not using an algebra. Should we remove it? Yeah, I mean, it's a huge dependency. I think let's just keep it light for now. We'll see later on what we're gonna do. Okay, other than that, we're good. Block on. The window event. So if we got a close requested, then we remove the window that got the request. And if we got no windows, then we just exit the application. And yeah, now resized, we just tell the manager to resize that window and it handles all the, surface bullcrap for you. And then here you just say self.manager get render tools, and then it gives you the output, the view, the GFX, the surface. This should probably be more of like you say get a frame and then it gives you that in a struct instead. I think that may be better, maybe. I'm not sure. Here we actually begin a frame. And we say frame.encoder, let render pass begin render pass. We should definitely make a GFX kind of like helper there, frame helper for beginning the render pass. Other than that, we just drop the render. I mean, here it's already being dropped automatically at this point, but yeah. And then we finalize and present. So frame submit output the present, and here keep the loop moving. Request redraw. No, don't do this. The request redraw should happen here. So yeah, keep the loop moving. So So let's just remove that part actually. And yeah, that's it. That's it. So what I changed, yeah, just a few things. Let's just amend. And let's amend the commit. So I think at this point I'm gonna take a little break and then we'll be back. Like around 15 minutes. Okay, see you then. Okay, back. Let's go. All right. So at least we don't have a memory. What is it called? Memory. Oh my, forgot the name. Memory leak. Otherwise, this would have maybe crashed. I mean, let me see how much memory it's using right now. It's been working for quite a while now, I guess. Did I unmute my mic? Yes, I did. Cool. Okay, let's see where this is in. I called it code checker, right? Or game. Yeah, game. So as you can see, 108 and 0.8% GPU. Yeah, sick. Because it's in VSync. So that's sick. Alright, so now the problem is, although we have all that code in there, we still have some things still kind of annoying. Like for example, the winit stuff. Because like you have to basically implement this application handler and stuff. So what we're gonna do is create a trait, our own simplified trait for that. But wait, do I want to start with that already, or maybe do something else before that? Hold on. So begin render pass. I'd like to take this begin render pass, copy it, like this part, and let's go to frame, GFX frame. Let's add a little helper function here really quick. Well, where is it? Or, you know, let's just put it maybe somewhere around here, fine. Pubif and render pass. And it's gonna give you back a wgpu. Render pass. And you just say self dot, well, obviously immutable self here, hold on, right, and what's going on here? In save? Bro, what? Why in save? Wait a second, what? Where is that again? Gain the RS. Do we have an in save block somewhere around here? No. So what the heck? I mean, I'm not sure what's in save here. Like, bro. Let's just say in wrap for a second. And we're gonna return. Oh. Yeah, that's very strange, to be honest with you. Frame.encoder. Encoder begin render pass. Yeah, that was strange. Like, what the heck? For whatever reason, option command encoders have a begin render pass, and it's an in save function. Why? I have no clue. Anyways, so what are we gonna do now? Here we're gonna need the view, and so the view is basically wgpu texture view, I think, right? And let's go. And here, instead of in wrap, we're just gonna pass in this guy, and this returns a result, I think, right? Or no? Can I return value for say temporary value? That's weird. As ref, I think. Let's go, and why this is not working? Let's see in wrap here. No, we still need the instead of as ref, we're gonna say as mute. Okay, so does this work? Yeah, so right now what we're gonna do, we're only gonna give it the wgpu color too. So we're gonna grab that color. Later on we may also add the depth stencil and stuff like that. But for now we're fine. Color wgpu color. So this is like the clear color actually. Right. So now hiding a lifetime consistently use that, I guess. Okay, cool. Now what we gonna do? Actually, can we right now do this? Yep, that works. Now what we're gonna do next is go back to game.rs, and instead of having this weird thing right here, in fact this whole thing pretty much, just gonna say frame.renderPass and the view, which is in our case the view, and here the clear color is this, and there we go. There we go. Finalize your present, blah blah blah. Okay, so that works. That works. Anyways, let's go back to business. So essentially, instead of having that whole block of code, right now we only have render pass, view, and the clear color. So that's sick. Alright, so now what we're gonna do next now is, I think what I'm gonna start to do, add like an input module. Or honestly, this whole boilerplate code is really making me like uneasy. So you know what I'm gonna do actually? I'm gonna copy that code, come here, and I'm gonna tell it to create a new module in the library which abstracts, which does the winit application handler stuff, and just like expose a simpler interface like on init, on update, on render. later on we'll add an input and time module, and also engine commands to create window and destroy them. And in like, yeah, I think that's from inside the trait impl. To avoid at the end of the frame, to avoid what? Races and borrow checker problems. Okay. Extracts it from game.rs. Oh, enjoy your break. hold on, bruh. Or actually, just remove this. This is a great move. Wrapping winit boilerplate into a custom abstract will make your game logic significantly cleaner. Okay. Well, it should handle the begin frame too and stuff, I think. No? Or never mind, let's just keep it like that for now. But as you can see, it's making a new runner. Like game is equal to my game and nvlogger init. Okay. Yeah, that's cool. That's sick. That's exactly what we need here. Alright, so we're just gonna copy this code and put it inside of app. And boom. Now we got a few errors here apparently. Nah. In journal. So now what we're gonna do, now refactor game Doris. Okay. Module app is private. Okay, hold on. Let's go to mod and make it public. And we're good. Great. So I think this is good now. This is pretty sick. Love that. Elp. What the heck is elp? Context active event loop. Oh wait, let's see what it did here. So it created a trait app which have on init, on update, on render, and then it obviously puts in on render window ID here, and we have a runner which takes an app and it stores a manager and if it's initialized or not. Now here we got an GFX manager by default. And what we do next here is set control flow. Honestly, this control flow, I'd like it to be configurable. That would be cool. Yeah, but for now, it's fine. Next up, handle OS level resume. So, cool. One-time initialization logic. And window event. Close requested, resized, redraw requested, blah blah blah. So yeah, that's quite sick. Love that. And it does the on update, on about to wait, and request draw all. Yeah, that looks perfection. Next step. Now I'm really thinking about the rendering part. Should we just take in, like, make a frame abstraction, like basically do this render tool stuff inside of, what is it called, inside of app, or should we do it in a separate render abstraction or something? Should we do the initial frame setup and final setup in app.rs, or should we create a new file, create a new module? Okay. Yeah, okay. Cool, cool, cool. Where is it? Okay, refactor. So as you can see right now in the redraw requested, we create an app context. We get the render tools and so on in the frame. And we do that other stuff. So that's sick. Now, we got a little problem here. So now we're gonna change this. You know, just refactor all, the whole file. Oh, we already added the app command. That's sick. Exactly, that's what I'm talking about. Create window, close window, etc. That's lovely. And here it passes in the commands. Perfect. Oh my god. Yeah. That's perfect. So now we got some other problems. Polster. Okay, should we do that or no? Polster block on. I mean, whatever, fine, who cares for now. Let's just take it from here and put it here. And let's go back right now to the app. And let's see. And sick. Now refactor game.rs. Okay, so now our code would be way smaller. Or you know, let me give it to the AI and see if it's exactly what it wants or no. In app to pass by value, since the runner has to clone anyway, pass it into the method. Pass by value. Okay, so where we're calling on render? Here. So you mean this view? You could just pass it in, and we don't need the view after that, right? No. And then here we could basically just take in a texture view. There you go. And here in game the RS, you could just do this, and boom. Okay, that's perfect. Perfect. Though I wonder if we even, yeah, that's fine. That's good. So as you can see right now, we have way lesser code to worry about here. So you just create your game, you create your runner, and you run the game. And yeah, that's sick. That's pretty sick. Does it actually print game initialized? Yes, it does. How about update? Currently we're just doing frame count. What if we print update here? I don't know what were we doing or why are we doing, but I'm enjoying so as you can see right now, the actual window colors is like updating, so that's sick. And we are getting the updates properly. So we're kind of like basically making an engine. We're making a library. And yeah. Now what we're gonna do next is let's add an input module. Let's add an input module. Now let's implement an input module. So we use the hash set. Okay. Internal update handlers used by runner. Okay, so let's just copy this part. In fact, let's already commit this stuff. So obviously the app runner is actually not like necessary. It's just there for you if you don't want to deal with the winit glue. But yeah, all right. So other than that, what we're gonna do here is we got this input.rs, and right now we're gonna basically refactor. Like, also, can you please implement the timer too? We need to include in the context so the user can actually read it. Yep. Before that, before refactoring game, can you also add time.rs module and use webtime crate. So it would basically be compatible with both web and desktop. And let's go. Okay, perfect. And this would take care of the time. Now we're gonna go ahead and refactor the app runner to include all of that stuff. So yeah. After that, we could do a more sophisticated demo because we're gonna have time and input, and yeah. And then we could look into other stuff like pipelines and so on. But anyways, so we're just gonna copy this here, and we're good. Now make a more sophisticated demo. Okay, let's try this. And we have some errors. Yeah, let's go to here, pub mode time and pub mode input, and let's go. Well, let's just try this first. And to spawn a new window, as you can see. Lovely, oh my god. And escape to exit. Oh, what? how did that segfault work? Maybe the segfault like happens when you like just close all, like destroy all the windows and then you exit the event loop possibly? Ooh, okay. Alright. That's interesting. Anyways, let it, it needs to do some more refactoring here to add like an exit command and so on. Can you add all the, can you pass a ctx struct instead of separate arguments too? Let's go. Okay, so we're just gonna right now copy this code, paste it here. And again, we have some problems, missing lifetime specifier, sure. Cannot move out of frame because it's borrowed. Let's go. Can we just fix this redraw requested part? No. Okay, let's copy this and let's go. Okay, so it needs clone, I guess. Derive clone. Would that fix it? No? You know, let me make it do that job. Fine. Even if the user returns surrender. And whoops, let's go to app again. Ah, it sucks. It sucks. Okay, now let's copy this again. Bro. It's hard to get lost at this point. Okay. Oh no, it's just, I guess, game. But it's not spawning anything though. Bruh. It says spawn a new window, but this time it doesn't spawn it anymore. That's strange. About to wait. It is. But it was working before, what the heck? But let's just follow along and see what it's gonna do. No. Yeah, it's lost at this point. So what we're gonna do? So the input is fine. The time is probably also fine. And this is fine too. And this is fine. And this. But the app, we'll see about that. The app RS. So I'm just gonna roll back the game and roll back the app and tell it to start over. Here's the last code we had working. Can you try to re-implement it, because this is not working. Problems start when we try to use a context struct instead of separate arguments. Whoops, well, not this actually. I mean this. My God. Let's go. Okay. I mean, come on. You know what? Just remove the context struct, or you know, let's go back. Let's go back where we said to add the context struct, because oh my God, that sucks. Okay. Yeah, here. This was the last kind of code. So game.rs, please. Thank you. And app.rs. Okay. Here we go. Cause what the heck was that, bro? What do you mean? I should have used version control. My god, I forgot. But here we got like commands. Yep. Okay, so where's the problem? On updates. So we don't have context.commands here anymore. Well, I guess for now we could just take this off here really quickly for now. And just do this for now. And say commands and input. This is very annoying. Yeah, you know? Yeah, we should start over in a new chat because this is getting hairy. And let's use version control too. Okay, let's run this. Okay, so this works as you can see. This one works. Alright, so this is our working version. And you know we're gonna do something quite interesting here, I think, which is to doloid zigzag. Where's zigzag? GitHub. Yeah. Let's go to Discord. And we're gonna add this to the path. Oh, I see. So I'm gonna put this in, let's say, some bin folder or something. And then I'm gonna basically add the bin folder here to the path, and let's go. So now I should be able to use it. There you go. So now what we're gonna do is we're gonna say zigzag dash dash help. So So zigzag, it's dash dash, well, dash dash path dot slash src slash core. And what we're gonna do next? Ignore. Yeah, that's good. A known argument. Huh. Is this like a regression or something? What distro are you using? I'm using Akashi OS. What the heck does it mean by unknown argument, bro? It was working. Let me grab another release. I think maybe the latest release something happened. What? Am I missing something? Why that and not a Ubuntu or Fedora or Arch? Because it just like comes in with all the NVIDIA drivers set up and everything set up for you, even fish shell, KDE, everything is well set up. And also it's like the fastest, because like it's basically compiled for modern architectures, while the other distros are just like regular builds. So yeah, and they also have a much snappier scheduler, but yeah. Okay, so this is very strange. Yeah, we know what I'm gonna do. I'm gonna go to a previous release. I think this could be like the regression here. You know what? Why I'm overcomplicating this? Well, never mind. Never mind. Let's go with this one. Save and open. And let's extract here. And let's go to home, bin, remove this and paste this one. And boom. Yeah, so it's a regression. Okay. So yeah. Alright, so let's grab our report here. I got little PC with i9. Name the GPU 3020 DDR5. If you ever need to run something heavy, I'll be happy. Oh, that's amazing. Thanks. So yeah, as you can see, it holds all the code of our project. So now we can take that and start a new chat. So staging belt directly into your GFX is excellent for performance. It allows you to efficiently string data from the CPU to GPU without blocking the queue. Great for handling WGSL uniform padding. Handles the tricky bytes per row alignment. In app, you use Bolster to create windows. Creating a window in your plan. Sure, I guess. Shader.wgsl. So where are we gonna put this? I guess maybe in the examples. Or actually, I could put it here, like in a folder called, I mean, this is part of the examples, right? So fine, let's say assets, yeah. And let's just put in a shader.wgsl, I guess. Yeah. Let's go install WGSL support plugin. Okay. Implementing the app trait. The shader is in assets slash shader.wgsl gen, the whole file. Okay. Just in case, let's do this. Oh, what the heck? Create core. No. I'm gonna say Kodachaku, wgpu Kodachaku, yeah. And let's go. Apparently no such field. Add the missing fields. Oh, we need a wage, or to simply bolster. Okay, block on. Though that's strange actually. Why the heck does it use context manager? Yeah, that's actually, but we had something for that, no? I don't know. Anyways, let's just go to the next thing. We're just trying to make this work. Add the missing fields, and let's remove this. And next up, what we got? Cannot find core. Yeah, let's just do this. And there you go. And obviously we're gonna need to change something really quickly, which is the fact that this game should change its working directory. 2 examples, I think, right now. And let's go. And why nothing's happening? Fixed a few issues, but nothing showing up. Okay. Nothing. Yeah, this sucks. Okay, let's see what it's doing. Is it at least creating a, yes, it is creating a window, but it's just not rendering for whichever reason. Well, we could just roll back this and actually give it that code first. Okay. Oh yeah, I'm still live. By the way, I tried your tool now. I tried like the new version, and I think it probably have a regression or something. So I used like an older version. Okay. So like the run path thing doesn't work anymore. It just says like invalid argument. Zigzag init? No, I didn't. Come on, bro, no. Can you refactor the whole game.rs? And here we go again. What this immediate sign is about? I see. Okay, we got a triangle, my god. My god, okay. So yeah, I think probably that crash is happening because you always have to have like one primary window, I think. Yeah, maybe. Yeah, sure, NZ. Okay, so that was a lot of crap. Oh man. Okay, so let's see if it used those functions that we have created. So it's trying to create a window, as you can see on the onInit function. And get graphics tools. So GFX, okay. Dynamically get the format the service actually wants. So we probably need to like give it some sort of helper function there. And here we just load the shader source. We need to create like a, you know, some sort of an asset loader. But yeah, create shader. And here we're using our GFX init buffer finally. Although it's not using the upload buffer instead. So yeah, it works, I guess. So the goal of this library essentially is you wouldn't have to bother with the wgpu winit stuff. So as you can see, it's pretty clear what's going on. So in version 5, let's add the shader. And we should be good to go, I think. And where's the game? Okay. This is the triangle. Now what we're gonna add? Should be, I guess, maybe in, is it manager or what? But wait, where's the surface format is being used again? Yeah, it's used here. We should add a surface format function getter into our abstraction instead of this. No, what the heck? Okay, get surface format, and we're good. Ah, not here. Where is that? Can we extract some other helper functions? By the way, can we create multiple windows now? Wait. Oh, we don't have... I'm not sure how that would actually work. But I guess let's try anyways. Is this valid? No, it's not. Key M, okay. There you go. Now if this key is held, then we want to create a new window. And how we do that is by... Well, currently we don't have access to that on the update. Let's just put it here really quickly. In fact, later on we should remove the input from the render entirely and only put it here, but yeah. Okay. But for now, can we just say this? Dot push. Create window. Takes 2 parameters, huh? What are the parameters? The window attributes and the GFX surface info. What? Oh. Ah, I see. So when you create a window, you can actually like set up this stuff. That's sick. I didn't notice that. That's sick. Alrighty, so you could like basically configure each window separately. That's interesting. But for now, where our code is, here we go. So we're just gonna say default, 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 and we're good. And it doesn't work for some reason. Oh man, what the heck? It was working. Okay, whatever. Let's try to... Come on, bro. One update doesn't have access to input yet. Just use it in render. Bro, come on. You know what? Let me give it those errors so it doesn't make those errors again. Oh. Anyways, let's put this in here. Cool. Next. Yeah, I mean, I could fix it myself, but I want to tell it the errors so it doesn't do these errors anymore, because oh my god, it's so infuriating. Wait, what? It's not even working now. Bruh, I think at this point I'll just end the stream and figure out what the heck is going wrong here. And I'm quite tired at this point. Yeah. Alright, so that was it, guys, for this stream, I think, for now. Because, oh my god. That was insane. Alright, so I'm just gonna throw away these edits, I think, for now. And this is actually kind of fine, though. This is also probably fine. And this is too. It's just the game. No. Let's try to regen. Oh man. No, let me do it by myself. Whichever the heck. Yeah, so where's the vertex buffer? Where are we creating that? Wait, what? No? Vertices. Okay, where's the vertices? Okay. Cool. Where's the iBuff? I guess? No? There's no index buffer, I guess? I mean, that's interesting. Does this at least work? Yes, it does. Yeah, at this point, I think I'm gonna end the stream because, oh my god, I'm so tired. So I could at least review what the heck is going on here. And we'll look into it tomorrow. So goodbye everyone, thank you all for coming in and see you later. Bye.